Hi everyone and welcome back. Now in today's video we are going to discuss on how we can create elastic IP resource with Terraform. Now the reason why we are looking into this specific video of creating an elastic IP is because of two reasons. First one is creation of elastic IP resource is very simple, the code block is quite small. Second is we will be using the elastic IP resource quite often in lot of videos as part of the course, and this is the reason why we have decided to create a dedicated video in which we'll also create a elastic IP. So before we go ahead and look into how we can create elastic IP in Terraform, let's look into what elastic IP is in first place. Now at a very high level overview, elastic IP address is a static IPv4 address in AWS, and you can create it and associate it with a EC2 instance. So let's understand this from a diagrammatic perspective where you have a elastic IP that you create and you have a EC2 instance. So after this elastic IP gets created, you get a public IP address here. So after EIP is created, you can associate it with a EC2 instance and then you can connect to the instance with this specific elastic IP here. So that's the basic of elastic IP, a very simple concept. Now looking into the aim of today's video, it is very simple, which is we are going to use Terraform to generate the elastic IP resource in AWS. Now before we create elastic IP through Terraform, it is important for us to understand on how we can create it through the AWS console. Again, I can say is that this is one of the simplest resource to create. Now generally if you go to elastic IP page, you can click on allocate elastic IP address. This is the region and all you'll have to do is allocate. And you see a elastic IP gets created for you. The type here is public IP. So once the elastic IP gets created, if you want and if you have EC2 instance, you can associate this elastic IP with the EC2 instance that is running in your environment, and this will be a static IP address here. So that's the overview. Let's go ahead and look into how we can create it through Terraform. Now within Google, whenever you want to create any resource for any cloud provider, you can say elastic IP Terraform AWS. It will take you to the right page. In this case, the page is AWS_EIP. Now, if you look into the resource of AWS_EIP, if you look into the sample usage, it is very simple. You can copy this up and within our KP Labs Terraform folder, let's quickly open this up with Visual Studio. Let's quickly create a new file. I'll just call it as eip.tf. And I'll paste the contents from the documentation here. Now at this stage, there are two arguments here. One is the instance argument and second one is the domain argument. Now as we were discussing in AWS console, the step number one is to create a elastic IP. After elastic IP is created, if you want, you can associate it with whatever instance that you'd like. At this stage, we want to keep it very simple. We just want to create elastic IP and no association is required. And this is the reason why this specific line of instance will remove. In fact, in the documentation page, you can also verify if the instance part is optional or compulsory. So here you see instance is optional. So I'll just remove it. Alright, so this specific resource is very simple. Just for simplicity, I'll also add a provider block and the region. I'll say US East 1 and the provider would be of AWS. Great. I'll save this. Now I already have the .terraform folder that got downloaded from our previous video, so I don't have to do Terraform in it once again. So let's open up the terminal. Let's go ahead and do a Terraform plan. It says one to add. I'll do a Terraform apply with auto approve. Great, our elastic IP is created. Now from the AWS console, you can open up the region in which you have created the resource. In my case, it is North Virginia. And within here, you see there is one elastic IP with 100.24.184.144. You can also verify this from the state file. So for example, whatever state that got created, let's verify. It should show the IP address as well, which is 124.184.144. Alright, so I hope with this at a high level overview you understood on how you can quickly create a elastic IP resource through Terraform and through AWS as well. Now one thing that needs to be noted is that you should not keep the elastic IP address idle in AWS. You will be charged unnecessarily. So whatever elastic IP that you create in any region, After you have completed the practical, make sure to remove it. In this case, I'll release it so that this IP no longer is with our account. And similarly for Terraform, I'll quickly do a Terraform destroy with auto approve. So the Elastic IP is destroyed, and always verify through console as well. So if you refresh the page, you see EIP no longer exists. So that's an overview, and with this we'll conclude this video. Hi everyone and welcome back. Now in today's video we are going to discuss about attributes in Terraform. Now in a longer run, when you're writing production environment code, attributes is one of the common things that you will be using for lot of integration. So with this said, let's go ahead and discuss about this important topic. Now at a high level overview, note that each resource that you create in Terraform has its associated set of attributes. And what are attributes? Attributes are the field in a resource that holds the value that ends up in a state file. Now again, this is a little confusing. However, with our diagram, things will become much more easier to understand. Where, let's assume that you have created a EC2 instance. Now after this EC2 instance is created through Terraform, in the state file, there will be some attributes associated with this EC2 instance, and these attributes will have some kind of a value. For example, we are using 4 attributes here. One is the ID, public IP, private IP and private DNS. Associated with each attribute is the value. ID is what is the instance ID after the instance is created. Public IP is what is the public IP of the EC2 instance after it gets created. Same for private IP, same for private DNS. Now each resource in Terraform has certain set of attributes, and whenever the resource is created, these attributes and the value are part of the state file. So let's go ahead and understand this. Now from the Terraform documentation, whenever you explore the resource page, the page also shows you what are the list of attributes associated with the resource. For example, if we go a bit down, so initially you have the argument reference, what are the arguments that you can add as part of the resource. Again, this is helpful. However, we are looking for attributes here. Let's go a bit down. And this part you see attribute reference is what we are looking for. So after a resource is created, all of these attributes get added as part of the state file. For example, ARN, ID, instance state, and so on. Similarly, for AWS EIP resource also, let's go a bit down. You have the argument reference, and then if you go a bit down, you also have the attribute reference, where for each attribute there is also a description on what it is all about. So in today's video, we are going to look into how attributes look like. So there are 2 resources that we are going to create. One is the Elastic IP and second one is the EC2 instance. And then we are going to look into the state file to see what are the attributes associated with this resource that are added as part of the state file. Alright, so this is a very simple resource block. We already know what this does. So let's directly go with Terraform apply. So from the CLI, I'll quickly do a Terraform apply with auto approve. So I've already run the Terraform init so that it saves us time. So we can directly go with apply. Great. So both of our resources are created. Just to verify, in the North Virginia region, if you refresh the page, there should be one EC2 instance that should be created. Along with that, you should have one Elastic IP in this region. Great. Now, if you look into the terraform.tf state file, the first resource here, the type is AWS_EIP, the name is LB. Now, if you go a bit down, you see there is a section of attributes. And under the attributes, these are the attributes that are created. One of the important attributes here is the public IP. So without going to the AWS console, if you want to see what is the public IP associated with the EIP resource, then you can directly look into the TF state file into the attributes of public IP. This becomes very helpful. Similarly, for the AWS_instance resource type, again there is an attribute section, and within here you see these are all the attributes associated with the instance. Now looking into the documentation, let's take an example of few attributes just for our better understanding. So this is the AWS_instance page. Let's say that we want to see what is the public IP associated with the instance and what is the instance ID here. So two things we want to see of EC2 instance directly from the tfstate file by not going into the AWS console. So let's quickly look into it. So these are all the attributes of the instance here. You have the AMI ID, the ARN and so on. So one of the attributes that we saw in the documentation is ID, and this is the ID. It ends with 8F6. So if you want to verify, you can do that. So from the AWS console, you see the instance ID is 8F6. The second attribute that we wanted to see was the public IP. Now if you see, the public IP here is 238.56. Let's verify this from the state file as well. If you see, the public IP attribute here is 238.56. Great. So I hope with this you understood what attributes are in Terraform. Now whenever you're writing Terraform code, attributes are one of the very important things that you will be using extensively. We will be discussing in great detail about attributes as part of the later videos. However, as part of today's video, I just wanted to keep it simple where we just understand the basics of what attributes are. Now just for revision, I have also added the details about the attribute reference screenshot in the next slide so that during the revision things become much more simpler. So that's the overview, and with this we'll conclude today's video. Hi everyone and welcome back. Now in today's video we are going to discuss about the cross-resource attribute reference. This is a very important video, and in any, or I would say in most of the production code that you will be writing in Terraform, the learnings as part of today's video is the one that you will be implementing quite extensively. Now in order to understand the things that we are going to discuss in this video, you have to understand the basics of attributes that we have already discussed in the previous video. So that is a prerequisite. Alright, so with this base set, let's get started. Now before we go ahead and discuss about referencing the resource attributes, let's look into a typical challenge that everyone would face if you're writing production level Terraform code. Now, one of the common challenges is that it can happen that a single Terraform file, you are defining multiple set of resources. It can be 1 resource, 2 resource, 3 resource, it can also be 15 to 20 resources. In such case, there can be a lot of scenarios where resource 2 might be dependent on some value of resource 1. So let's go ahead and understand this with a small diagram where as part of your Terraform file, there are 2 resources that you are defining. First one is the elastic IP address resource. We already know what this does. Second is the security group resource. Now, the requirement here is that in this specific security group, you want to have a rule which allows the port 443 from the elastic IP. Whatever elastic IP value that gets computed after this EIP resource gets created is the one that you want to whitelist in the security group resource. Now at this stage, when you have defined both of them, elastic IP address value you will only get after the elastic IP is created. So the question that comes is, how can you whitelist this EIP in the security group resource? Some might say that first you can go ahead and create a elastic IP. Whatever public IP that you get, you add it as part of your security group resource in Terraform. However, this is very simple way of doing things, and this is not the right way as well. So what you want is, you want a solution in which once the elastic IP that gets created, automatically whatever the value associated with the public IP attribute is, you want it to be added as part of the security group automatically. So let's look into what is the workflow that we are expecting. First resource as we are discussing is the EIP resource. Once the elastic IP that gets created, you will get some kind of a value. So this is the static public IP that you will get. After this value is something that you receive, then the security group resource should be created in a way that the value as part of the security group resource should automatically be computed, or to be more precise, it should automatically be taken from the elastic IP resource block after it got created here. Now the question that comes is how to add the elastic IP address here. For example, this specific resource block, it creates a security group in AWS. Now, while creating security group, there is a specific argument of CIDR IPv4 where you have to add the IPv4 block, which is this IPv4 associated with the elastic IP. So the question that comes is, how can you add it over here in a way that it automatically gets computed after the elastic IP is created in AWS? Now, in order to solve this scenario, the attributes part of the elastic IP proves to be very useful. So in such case, you have to analyze what are the attributes that are stored as part of the EIP resource. Now, if you look into the documentation, one of the important attributes here as part of the EIP resource is the public IP. You see, the public IP attribute, the description contains the public IP address. Now let me also quickly show you. So in the documentation of AWS_EIP, if you go a bit down into the attribute reference, so here you see you have a public IP attribute that gets added as part of the state file, which contains the public IP address, whatever that gets created. So based on our learning, this is what it looks like. So after the elastic IP that gets created, in the attribute you have a public IP and the appropriate value will be added. So what is the solution here? We have to find a way in which this specific attribute value of public IP is referenced in the CIDR IPv4 block of the security group. So from the diagrammatic perspective, it would look something similar to this, where after the elastic IP resource is created and after the attribute is added as part of the state file, then the security group resource under the CIDR IPv4 argument, it should automatically take this value and it should add it over here. And this is what we are planning to understand in today's video. Now, one of the great features that HashiCorp provides is cross-referencing the resource attributes. So you can reference the attribute of one resource to be used in a different resource. And this essentially is a solution to the challenge. Now, if you look into the overall syntax of cross-referencing the resource attribute, it looks something similar to this, where you have to specify the resource type, the resource local name, followed by the attribute that you want to reference. So if you look into the final solution, it would look something similar to this, where under the CIDR IPv4 block, you specify the exact resource type, which is AWS EIP, the resource name, which is LB, followed by the attribute associated with the resource, which is public_IP. So now what Terraform will do, Terraform after creating the elastic IP, then it will create a security group, and while creating the security group rule, it will fetch this specific value from the public IP attribute of elastic IP. It will add it over here and it will then apply the security group rule. And this is what keeps the overall things much more simple and effective. So let's do one thing. Let's have a quick demo to understand how things work. In the next video, we are going to look into the practicality aspect of this. So at this stage, let's go ahead and keep the theoretical part well understood. Now for today's video, we have a file of cross-reference attributes.tf. Again, this is just a demo video. We are not starting with the practical from scratch. Now, what this file has defined, it has defined a elastic IP resource. Very simple to understand. It has defined a security group resource and the name of a security group is attribute firewall. So this will just create a simple security group, and you also have a security group ingress rule. So it will create a new inbound rule as part of the security group, and within the CIDR IPv4 block, this specific section, you see we have a cross-reference resource attribute here. So we are referencing to a public_IP attribute of the resource type of AWS_EIP with a local name of LB. So whatever the public IPv4 attribute associated with this resource, whatever value is there, it will be computed as part of this block and a security group rule will be created. Now at this stage, let me also show you, we do not have a terraform.tf state file here. No resources are created. All of the resources are going to be created anew, and we are going to see on how things get computed automatically. This is one of the great benefits of Terraform. I really like it and it makes life simple. Now from the CLI, again note that this is a demo video. Just as a reminder, I'll quickly do a Terraform apply with auto approve. let's see whether the EIP, the security group and the rule gets created. And great, it took a few seconds and all of our resources are created. Now from the AWS console, let's first verify the Elastic IP here. So our Elastic IP ends with 238.140. Now after our Elastic IP is created, let's also verify the security group. Now at this stage, we have a security group of attribute firewall. If you explore the security group here, you see on the port of 80, the source is the EIP, which is 238.140, which is nothing but this Elastic IP here. Now, one thing that we have to keep a note of is that this specific security group rule requires the Elastic IP value to be added. So Terraform is intelligent to understand this specific dependency. And this is the reason why, if you would have looked into the output here, first thing that Terraform does is it creates the Elastic IP. Only after it creates the Elastic IP, here you see the Elastic IP creation is completed. Only after the Elastic IP is created, then it creates the security group and then it creates the security group rule. So when you have such kind of a dependencies, Terraform understands it and the resources are created accordingly. Now one more interesting thing that I wanted to show you before we conclude this video is that in this specific code block, there is one more cross-reference of resource attribute which has taken place apart from this. Can you identify where exactly we have referenced the resource attribute in one more place? And the answer is this security group ID. Now, if you look into our resource of VPC security group ingress rule, let's look into the arguments. One of the important arguments that you have to mention, and it is also required, is the security group ID. Here you have to specify the ID of the security group. Now generally, whenever you create a security group in AWS, it comes with an ID. So this is the ID that you have to mention here, something similar to this. Alright, it looks something similar to this. Now the challenge here is that this specific rule that we are planning to add, we want to add it in the security group called as attribute firewall, which has not yet been created. So if a security group is not created, you will never get the ID as well. ID you only get after a resource is created. And this is the reason why within here also we have referenced the attribute. What is the attribute that we have referenced? You see, first let's look into the syntax. Syntax is resource type, the local name followed by the attribute. So the resource type here is AWS security group. This is easy to understand. The name here is allow_TLS. This is a local resource name followed by the attribute of ID. Now, if you look into the documentation of AWS security group, let's look into the attributes here. In the attributes associated with it, one of the important attribute is ID. What exactly it means? It means ID of the security group. So after this security group resource gets created, in the state file, there will be an attribute of ID with the appropriate value. And then this specific part will get computed. It will fetch the value of that attribute here. It will add it here internally and then the overall resource gets created. And this is the reason why if you see only and only after the security group resource is created does the Terraform tries to create the ingress rule resource, because there is a dependency here. If Terraform would directly try to create the security group rule resource, it will fail because it is dependent upon the ID value attribute of the security group resource. Alright, so I hope with this at a high level overview you understood on how we can reference the resource attributes across multiple resource types in Terraform, and with this we'll conclude today's video. Hi everyone and welcome back. Now in today's video we are going to start with a practical related to the cross resource attribute reference in Terraform. Now the practical will be based on the workflow that we had seen in the earlier slide, where we want a Elastic IP value to be whitelisted as part of the security group. Now as part of this there are three primary resource types that we will be needing. One is the elastic IP resource, second is the security group resource, third is the security group rule resource. Now I already have the documentation page associated with all the resource open in different tabs. I'll also be adding this link in our GitHub page for easy reference. So the first resource is the EIP. Let's go ahead and quickly copy the resource here. And within our KP Labs Terraform folder, I'll quickly create a file called as cross-reference attributes.tf. And within here, I'll add the resource of EIP. Let's remove the instances part. This is not required as part of today's video. The second resource that we need is the AWS security group. Let's also copy the basic structure of the security group here. Let's add it. We'll remove the things that are not required and are optional. So our security group resource becomes 3-liner. Now the name of the security group, you can just say attribute-sg. So this is the second resource that needs to be created. And the third one is the security group rule. Let's also copy the basic example associated with it. So let's copy this and I'll add it over here. So as we were discussing, you already have a cross reference of resource attribute of security group ID that is added here. The next important part here is the port. If you look into this specific diagram, we need a port of 443 to be allowed from the elastic IP that gets created. So here I'll just say port number 443. Now, one more thing that you have to keep a note of is that in the security group ID, the name here of the security group, the local resource name is example. However, here it is allow_tls. So you either change over here or you either change over here, whatever suits you. So just for simplicity, I'll just change over here. All right. So whatever ID that gets associated with this security group will be computed as part of this argument. This is one part. The next part is the CIDR IPv4 block. So here instead of this specific address, we need the address of the elastic IPv4 block here. So one of the things that you might do initially, as we know the syntax, let's revise. The syntax is the resource type, the local resource name and the attribute. So the resource type will say AWS_EIP. The name here is LB, followed by the attribute where the public IPv4 is stored. So from the documentation, you have to see in which attribute this resource is storing the public IPv4 address. You can always check it from the documentation. In the attribute reference, there is one part where the public IP address is stored, which is public_IP. So this is what you are going to add it over here. All right. So at this stage, the format is very similar to the security group idea. You see, everything is very similar. The resource is changed. So let's do one thing. Let's go ahead and verify if this code works. Now from the CLI, I'll quickly do a Terraform plan. At this stage, it is showing 3 to add. Now, when you do a Terraform apply, again, this is an important learning that Terraform plan, if it succeeds, does not mean that the Terraform apply will also succeed. All right. Terraform apply can fail even though the plan is showing successful here. Let's verify that. So if I do a Terraform apply, let's do a auto approve. Now at this stage, what has happened is the elastic IP resource is created successfully. The security group resource has been created successfully. So this is the security group resource. Now the third resource, which is the VPC security group ingress rule, this is where the issue is. Now generally in production, when you see something similar to this, you have half infrastructure that is created. Let's verify it. Now from the AWS console, let's verify the elastic IP. You see there is one elastic IP that is created, which is 233.58. You should also have a security group that is created. The name of the security group here is attribute-sg. However, associated with this security group, there is no security group rule because our resource type failed. So what exactly does this error says? It says invalid attribute value. It is also showing you the exact line where the issue is. Now, if you look into the error here, It states that attribute CIDR IPv4 value must be a valid IPv4 CIDR block that represents a network address. And it is also showing what is the value it got. Instead of this, it got this value, which is 35.154.233.58. And still it is showing an error. Now, if we copy this, and just for simplicity, I wanted to show you one thing. If you manually add this IPv4 address here, let's verify if it gets successful now. I'll clear the screen. I'll do a Terraform apply again. Again, you see we are getting the same error. So why exactly this error is coming? Let's look into it. Now, generally in AWS, whenever you are adding a new rule, let me quickly show you. Whenever a new security group rule is added for any port, whatever IP address that you add, for example, let me just copy this IPv4 address. I'll add it over here. Now, when you just add it directly, immediately here you see you're getting an error, which states the CIDR block has to be specified. So if I try to save this, I'll not be able to. So you have to specify the exact site. It is also showing you like /32. So this is much more better. So generally, if you have something like 10.77.0.0, you will have to add the exact part, which is either 16, 24, 32, etc. So if it is a single IP address, then it needs to be /32. All right. So what you need to do, you have to find a way in which this CIDR IPv4 block will be this value followed by 32. So something similar to this is what you need. So let's remove this part. Let's add the attribute again. All right. So this gets computed followed by 32. Something similar to this is what you need. However, when you try to directly use this block, this will fail. Let's verify. So when you do a Terraform apply auto approve, you see it failed again. So what you need is, first you need the value to be computed, because you need this specific value to be computed. After this value is computed, then you need the final value to be added with /32 block. So the first part is, let me show you. So the first part is to compute this, which Terraform will do easily. Then after this gets computed, then you want Terraform to add a 32 here, something similar to this, and then pass this value as part of the CIDR IPv4 block. So if you want to achieve this, then you need a string interpolation. So what string interpolation does is, let me quickly show you. So you will have to add it in a syntax something similar to this. All right. So this part over here is what we refer to as string interpolation. So now what Terraform will do, Terraform will first calculate whatever value associated with this block is, then it will add a /32, and then it will pass it to the CIDR IPv4 block. So with this, let's save it. I'll clear the screen and I'll do a Terraform apply. This time you see our apply has been completed successfully. And if you see the value of CIDR IPv4 block, this time it is the IPv4, which is the EIP followed by /32. So if you have to verify it, let's open up the security group again. In fact, let's refresh this. Let's search by the name, which is attribute SZ. And if you look into the inbound rule, you see the EIP is computed. Now, one more thing that I wanted to share before we conclude this video is that whenever you see that your infrastructure is created half-half. So earlier we had 2 resources that got created, one failed. Then in the next apply, you ran the Terraform apply, it succeeded again. Now from the infrastructure point of view, this is not going to be an issue, but generally it is recommended that Terraform should be able to create the entire infrastructure in the first go itself. Even though if you try apply 2-3 times, it is not going to be an issue, but just as a smooth process, you should ensure that it gets created in the first go. So let's do one thing. Let's destroy the infrastructure that we have created. Oops, we made a small typo. It should be destroy. I'll do an auto approve. And after it is destroyed, you can run the Terraform apply once again. And this time we have ensured that the entire process is smooth and everything that gets created is created in one go. And this is how you should be able to create the production level code for your organization. Now I have also added a slide related to string interpolation, where we were discussing that anything that gets added as part of this block, which is the $sign followed by the curly braces, anything that is added over here, Terraform will go ahead and replace it with the calculated value, whatever it may be, and then it passes it to the appropriate argument while running the Terraform apply. So this is like a placeholder whose value needs to be calculated by Terraform, post which it will be passed on. Now this string interpolation is useful in a lot of cases, specifically whenever you are using expression. We are going to discuss things in more detail at a later stage, but it is not always necessary that you have to use string interpolation. For example, in the security group ID, this also is one of the values that will be computed by Terraform, but we have not used string interpolation here. However, in the CIDR IPv4 block, since we are also adding the /32, this is where things are needed at a very high level overview here. So that's a quick overview. So with this, we'll conclude today's video. Hi everyone and welcome back. Now in today's video we are going to discuss about output values. So at a very high level overview, output values, it makes information about your infrastructure available on the command line so that it can be exposed to other set of Terraform configurations as well. Now again, this part is a little confusing. Let's go ahead and understand this with an animated diagram, where let's assume that you have a user, you have Terraform. Now user through the Terraform code has instructed to create a EC2 instance. Along with creation of EC2 instance, user has also instructed Terraform to provide the public IP of the EC2. Now generally what happens is when you create a EC2 instance resource, all the details associated with that you can get it from the console. But let's assume that you do not want to log into console to fetch a specific details like the public IP. So you can explicitly request Terraform to also provide you the public IP. So now what Terraform will do, it will create the EC2 instance in AWS, it will fetch the information of the EC2 instance, and the IP address of the EC2 instance, whatever it may be, will be provided back to the user. Now this has multiple set of benefits, but at this stage, let's quickly look into how this workflow would really look like and what happens if this workflow is not present. Now for today's demo, in our KP Labs Terraform folder, I have one file called as output-values.tf. Now this file is very simple. All it is creating is the resource of AWS_EIP. So it is creating a public IP in AWS, and that's about it. So let's do one thing. Before we proceed further, let's do a Terraform apply. So from the CLI, I'll quickly do a Terraform apply with auto approve. Alright. So now you see, once the IP address has been created from the CLI, you do not really see the way in which you can fetch the public IP. Now, if you want to fetch the public IP, what generally users would do, they will typically log into the AWS console. The public IP was created in North Virginia region. So they'll go to North Virginia region, they'll go to Elastic IPs, and from here they can copy the public IP. So this is one way. However, this takes a lot of time, and again, there are much more efficient ways in which you can output a specific information if you want to. So based on the requirement, we have a use case where Terraform should create the Elastic IP, which is the public IP, and it should also output the value of that IP. For example, in this screenshot, you will see after the Elastic IP is created, it also shows you the Elastic IP output here. So this is what we are trying to achieve. So let's quickly look into how this can be achieved. Now within your Terraform code, you can make use of output. You can give a name. Let me just call it as public-IP. You can give any name if you'd like. And within here, you can specify the value of the attribute of this resource. So your understanding about the attribute of a resource is important here. Now, if you look into AWS_EIP resource, let's look into the attributes that are provided. Let's go a bit down. One of the attribute here is public DNS. You have public IP as well. So depending upon what you want to be outputted as part of CLI, you can use the appropriate attribute. So we want the public IP to be outputted in the CLI. So what we'll do, we'll use the resource address here, which is aws_eip.lb dot the attribute name. In my case, it is public_IP. Alright. Now in the earlier part, the resource was already created. Now let's go ahead and do a Terraform apply with auto approve once again. Now this time you see, you get the public-IP followed by the IP address here, and this can make things much more simpler. Along with that, you can also have a certain level of customization if you'd like. For example, let's say I specify HTTPS followed by a little level of customization, and I'll say sometimes what would happen is the application would run on a specific port like 8080 with HTTPS. So not only you'd like the IP address, but you'll want the entire URL to be present. Alright, so let's go ahead and try this out. So I'll clear the screen. We'll run the same Terraform apply command once again. And now you see, you get a nice URL that you can copy directly. Along with that, in case, let's go ahead and remove this part. In case if you do not decide to specify a attribute, alright, you just specify the resource address aws_eip.lb. Then all the associated attributes will be presented to you. So let's clear the screen here. Let's do a Terraform apply once again. And now you see, you're getting all the appropriate attributes here. One among them is the public IP, you have public DNS, and all other details are available as well. Alright, so I hope with this at a high level overview you understood the basics of output values. Now one more point before we conclude is that output values that we are discussing here, it proves to be very important when you want to have certain collaboration between multiple Terraform projects. For example, you have a project A here, you have a project B here. Now project A and project B can be in a different Git repository as well. It need not be in the same folder, it can be in a completely different places. Now let's assume that project B wants certain details associated with the code that is created through project A. For example, Elastic IP is created in project A, so the project B requires the public IP, the actual public IP associated with the EIP resource. So in such case, what project B can do is that it can fetch this specific information from the output values associated with the state file of project A. Now we will be discussing about this specific architecture at a later part of the course, but at an overview I just wanted to add the detail here as well to show that output values is not just about outputting the data in the CLI, it has wide variety of use cases in production environments. Now generally, if you look into the terraform.tf state file, you see there is a specific section related to output, and the public-IP is what we had given the name of the output here. And within here, in the value section, you have all of these values. So a Terraform project which is in a different location altogether, the project B or another project can fetch the values that is part of the outputs, considering that it has access to the TF state file of the project where output values are created. Anyway, so again, we are going to discuss about this in detail at a later part of the course, but at a high level overview, I hope you understood the basics of output values, and with this we'll conclude today's video. Hi everyone and welcome back. Now in today's video, we are going to discuss yet another very important topic as part of Terraform, which is the Terraform variables. Now generally in any production environment that you will be working with or any larger code base, variables are one of the common things that you will see as part of the code. So let's go ahead and understand the challenge, post which we'll look into how variable allows us to solve that specific challenge. Now, one of the important things that we need to keep a note of is that whenever you have a larger code base which has repeated static values, it will create a lot of issues and manual work in the future. And ideally in any code that you write, the repeated static values should always be avoided. So let's go ahead and understand this with an example. which states that you have a VPN server in your organization and you want to whitelist the VPN server IP address in the firewall rule for 5 specific ports. If you look into the firewall rules, it would look something similar to this. So you have in total of 5 ports, 80, 443, 22, 21 and 8080, and the VPN IP needs to be whitelisted. So this is the VPN IP that you see over here in the CIDR block section, and in all of the 5 ports you have a VPN IP that is whitelisted. Now among this, which is the repeated static value that you see? It is the VPN IP. And this is a very simple and a small example. Whenever you are working with larger organization, they have hundreds of rules. And when you have the VPN IP added in hundreds of rules, it is a repeated static value and it is going to create a lot of work for you in the future. Now just for simplicity, I have also added a reference screenshot related to it where you have a firewall rule here and in the CIDR IPv4 block, you have the VPN IP. So this is a firewall rule 1. Then you have firewall rule 2. Again, the port differs, but the VPN IP remains to be the same. So similar to this, in a larger organization, you can have hundreds of rules where this static value would be present. Now, in order to avoid specifying the repeated static value in your code, the better approach would be to define this static value in a central place. For example, let's say that you have a central location where you specify that the VPN IP is going to be this. Now, what you can do is that from the code of your Terraform, so there are 2 rules over here, you can create a logic in which the CIDR IPv4 block, you see it states fetch from the central location. So instead of hard coding the IP everywhere in your code, you just say fetch from the central location. So now what it will do, whatever central location that you have defined, it will fetch the IP from the central location and it will be computed internally. So tomorrow, let's say that you have to change the IP address of the VPN server. You have a new VPN server that has been configured and it has a new IP. So you don't have to modify all of the firewall rules with the newer IP. All you have to do is that in the central location, just replace this with a newer IP and that's about it. In the next Terraform apply, it will automatically fetch the latest IP from the central location and the firewall rules will be updated. So this kind of an approach is what you should be using in the production environment, and this is going to make your life simple. Now this better approach that we were discussing can be achieved in Terraform using the feature of variables. At a high level overview, the Terraform input variables are used to pass certain values from outside of the configuration. So let's take an example where you specify some key value pair here. For example, VPN IP, you have an IP address of the VPN server. You also have one more variable with the name of app port and the value is 8080. So this is a different file altogether, and the Terraform code that you write, you do not hard code the values here. You create a logic in which the value associated with these arguments can be fetched from this central location. You can also refer to as a variable file. For example, if you look into this code, there are 2 specific variables that you have defined. One is associated with the CIDR IPv4 block. You see, you have var.vpn_ip, which is this specific block. So it will automatically take the IP value here. Similarly, if you see from port and to port, here also instead of defining the port of 8080, you have specified var.app_port. So now Terraform will automatically look into the value of app_port from the central location that you have defined, and the 8080 will be computed internally for you. Alright, so I hope with this at a high level overview you understood what variables are all about. So let's have a quick demo to understand this from practical point of view as well. Now similar to the screenshot that we had seen as part of the PPT, we have a small code where we have variables that are used. Now again note that this is a demo video, we are not starting with a practical from scratch. We'll have a different practical video where we'll be starting things from scratch here. Now, as part of the file that we have, there are 2 resources that are defined. One is the security group resource, which creates the security group, a very simple resource to understand. And the second one is the security group rule resource. Now, within the rule resource here, if you see the CIDR IPv4 block is var.vpn_ip. Now, you can also hardcode the IP address of the VPN server, but as we were discussing, this in a longer run, it is going to create issue, specifically when you have a large code base. For example, currently you only have one rule, but what happens if you have hundreds of rules where the VPN IP is whitelisted? Then, in such cases, if the VPN server IP changes, then in all of the 100 rules, you will have to manually modify the code block. This is something that you do not really want. And this is the reason why what you do, you make it a variable. So here you see you have var.vpn_ip, and also for the port you have var.app_port. So var here states that this is a variable and vpn_ip is the name of the variable. Now, associated with this specific code, we also have one more file called as central-file.tf. Now, if you look into the central-file, you have a variable with the exact name of vpn_ip that you have defined here, and it has a specific value. Similarly, for app_port also, you have a specific variable with the name and you have a value that is associated. Now, generally, whenever you do a Terraform plan, let's see if the values are automatically being computed for us. So here you see for the VPC security ingress rule, the CIDR IPv4 block is automatically taken from variable. Similarly, in the from port, you see 8080 is automatically taken from the variable. Now, whenever you change the variable, for example, let's just change it to 22. Just for simplicity, I just wanted to show you. Now, if you do a Terraform plan, you see automatically the code base has taken the latest value from the variable. Great. So I hope with this at a high level overview, you understood what variables allows us to do. Now, before we conclude today's video, let's quickly revise the benefits that variables provide. The first benefit is that it allows us to update the important values in a central place instead of searching and replacing it throughout the code, saving time and potential mistakes. Now, generally what happens is that in a larger code base, when you have say hundreds of firewall rules, when you want to change a specific VPN IP in say 50 or 60 firewall rules, you are doing it manually. Now, in such case, what happens is there are higher chances of you making a mistake. And this is the reason why you should always avoid the repeated static values. Along with that, since you have a central location and there is only one place where you have to modify the VPN IP, it is going to save you a lot of time. And the second pointer also is quite related, which states that no need to touch the core configuration file. This can avoid human mistakes while editing. Now, since you have a central file where variable and its values are stored, you don't have to touch the main Terraform configuration file where the resources are configured. So in production environment, this is very important because if you touch the Terraform configuration file, there are always some chances of mistakes, which you can easily avoid if you're using the variables here. So that's a very high level overview about what Terraform variables are all about. And with this, we'll conclude today's video. Hi everyone and welcome back. Now, in the earlier video of Terraform variables, we were looking into the challenge that you will face related to the repeated static values and how it can be solved using the Terraform variables feature. So today is going to be the practical video where we are going to discuss about how you can create the variables and also some of the important aspects related to it. Now for today's practical, in the KP Labs Terraform folder, I have a file called as terraform-variables.tf. I have also committed this base file as part of our GitHub, so you can directly reference from here. Now what exactly this file does, it creates a security group resource in AWS, and after security group is created, it creates 3 rules as part of the security group. One rule is for port 8080 over here, second rule is for port 22, and third rule is for the port of 21. Now generally whenever you are creating variables in Terraform, you have to identify which is the repeated value that is being used. So whenever you read the Terraform configuration file, you will be able to identify it easily. Now within here, there is one specific value that is repeated, which is as part of the CIDR IPv4 block. So this is the IP address that you see is added in all of the 3 security group rule resource. So this is a repeated value which we want to make it a variable. So first, what you can do is you can create one more file. Let's just call it as central-location.tf just for easy understanding. Now within this specific file, you create the variable along with the value. For example, the syntax is variable. You specify the name of variable whatever you want. For example, I'll say VPN_IP. Alright, you can give any name, and in this variable, you give a default value, and in the default value, you add this specific part. So I'll copy this and I'll add it over here. Alright, so this is what variable is. Now, the next part, as we're discussing in the PPT, is that we have to create a logic in which associated with the argument, we have to specify that the value of the argument needs to be fetched from the central file. So in order to achieve that, what you can do, you have to remove this and you have to specify that the value of the CIDR IPv4 block needs to be fetched from a variable. So how do you define that? You define it with var. Now var dot the name of the variable. So in this case, the name of the variable is VPN_IP. Alright. So this is how you define it. So now Terraform can understand that the value associated with this is in a variable called as VPN_IP. Then Terraform will look for a variable called as VPN_IP, and whatever value associated with this variable is, it will be computed over here internally when you do a Terraform plan or apply operation. Alright. So let's copy this, and in all of the three CIDR IPv4 block rules, we'll replace it over here. Once done, I'll save this file. Once the file is saved, let's go ahead and open up our terminal. Now within a terminal, Terraform init is already run from my side, so I'll directly do a Terraform plan. So at this stage, we are getting an error stating reference to an undeclared variable. Now this is probably because we have not saved our central location file. So let's also go ahead and I'll save this. Let's clear the screen. Let's do a Terraform plan. This time you see things are working, and if you look into the security group rule for CIDR IPv4 block, the value from the variable is automatically taken and it is added over here. Similarly for all of the rules. So let's do one thing. Let's also go ahead and do a Terraform apply with auto approve to ensure that the variable part is working perfectly well. So a security group resource is created successfully. Now within our AWS console, if you look into the security groups, you have the Terraform firewall security group that we have created. And if you look into the inbound rules, you see there are multiple inbound rules created for 21, 80, 80 and 22 with the VPN IP. Now since we have made it as a variable, tomorrow if a VPN IP changes, the core Terraform configuration file need not be touched. All you will have to do is that you can open up the central location file, change the IP address of the VPN variable. So let's just call it as 200. Just for an example, I'll save this. Now, when you do a Terraform apply with auto approve, you see all of the rules are modified with the latest configuration here, which is 200. And similarly, if you refresh this page, you see all of the IP addresses are modified. Alright, so I hope with this you understood the benefits that variable provides. Now generally whenever you're writing the production level code in Terraform, one thing that you have to keep in mind is that as minimum as you touch the main Terraform configuration file, the better it is going to be. Now currently the code looks very simple, but in larger production environment you have a very big Terraform configuration file. And this is the reason why as much as you can, the values you can make it variable, it is recommended to do that. For example, here you see you have some ports that are defined like 8080, then you have 22, then you have 21 and so on. So generally in production environments, even the ports are made as a variable. So let's also quickly do that. I'll say variable of app_port. And the default value here, I'll just say as 8080. Similarly, we'll create one more variable of SSH_port. The default value here is 22. And the last one is FTP underscore port, and the default value here is 21. All right. So now let's also make these as variables. So I'll say var.app underscore port. Let's just copy it in both the places. Then we have var.ssh underscore port. Again, let's copy it in both the places. And last one is var.ftp underscore port. Let's copy it in both the places. I'll save this file and I'll save this file. Now at this stage, there are no changes. It's just that we made some configuration change to make the values be fetched from variable. So now if you try to do a Terraform plan, it will show no changes are required. Alright, as expected, there are no changes here. So this specific code that we have added, this is a much more production ready code. So even if you give this code to another user, all he has to do is he does not have to modify the main Terraform configuration code. All he has to do is he has to open the central location, and whatever new value he has to add, he can add it over here. This makes things easy and less room for mistakes. This is one part. Second important part is that instead of defining this as central location, it is recommended to have a standard naming structure. So it can happen that in this organization, I am calling it as central location. In different organization, they might name it differently. So this is something that you should avoid. So the standard naming convention for this file is variables.tf. Alright. This is a very important naming convention that you should follow. Again, even if you have a different name, it is not going to create an issue, but just from the production level best practices, this is the standard convention that you should be following. Now, before we conclude, I also wanted to show you the documentation related to the input variables that we were discussing. Now, variable is a larger topic because there is a lot of customization that HashiCorp allows us to do. However, the core functionality is this, and we have already discussed. Now, if you look into the documentation, as we were seeing here, there are a lot of arguments that you can define as part of variable. One of the important arguments that we have discussed in today's video is the default argument, which is the default value that the variable has. Now, apart from that, there are so many arguments here like validation, sensitive, nullable type, etc. We are going to discuss about these at a later part of this course. However, the aim at this stage is to understand the core concept of variables. Along with that, before we conclude, let's take one more argument over here, which is description. Now, generally, whenever you are defining variables in production environment, it is very important that you also provide the description associated with that. Otherwise, any new user who has joined the organization, from the name, if naming convention is not done right, he'll not be able to understand what the variable is all about. For example, for the VPN IP, you can add a small description here, which states that this is a VPN server created in AWS. Alright, so now once you have the description, any new user who is looking into your Terraform code, he'll be able to quickly understand what this variable is all about. And this is the reason why, along with the default values, in case if you have, description is very important. Great. So that's a very high level overview about the practical aspect of the core Terraform variable concept, and with this we'll conclude today's video.